In section 2.6, we talk about linear inequalities. So first thing is let's talk about shading. We shade to the left if we have a less than, which we use as an open circle, or less than or equal to, which uses a closed circle. We shade to the right when it's greater than, and we use an open circle, or greater than or equal to, which has a closed circle. And so a little trick to help you remember is the arrow points to the direction that you need to shade. So for example number 1, let's insert the proper symbol between the numbers. We have -2 blank 3. Well, regardless, this is a negative number and a positive number, and a negative number will always be less than a positive number. What about -4 and -2? People get two negatives confused all the time. So if both of your numbers are negative, the number that is bigger is actually more negative or smaller than the other number. So because we have a -4 and a -2, and the 4 is bigger, that means that it is smaller than the other one. So -4 is less than -2. What about 1/2 and 1/3? Well, let's go ahead and put these with the same denominator so we can compare the numerators. So we've got 1/2 and we've got 1/3. And so we can make both of these denominators 6. So we're going to multiply the first one by 3 on the bottom and the top. And we're going to multiply the second one by 2 on the bottom and the top. And so we end up with 3/6 and 2/6. Now that we have the same exact denominator, we just compare the numerators. So what number is bigger, 3 or 2? Well, since 3 is bigger, that means the arrow needs to be opening towards the 1/2. Now what about when we solve linear inequalities? Is there anything different because we have these weird symbols instead of an equal sign? So we solve these the same exact way that we solve equations. We just have to remember two important rules. So whenever you multiply or divide both sides of the inequality by a negative number, you must flip the inequality sign. So if you multiply or divide by a negative number on both sides, then you have to flip or switch the sign. If you switch the sides, then you must switch the sign. So if I have a number is less than x, if I want to make x go to the left-hand side, I have to flip the sign as well. So let's try this with example number 2. We want to solve and graph 6x plus 3 is less than or equal to 2x minus 5. So 6x plus 3 is less than or equal to 2x minus 5. Remember, these work the same way unless you multiply or divide by a negative number. So I am going to subtract 2x from both sides so that I can get it all on one side. So on the right hand side it cancels. And we get 4x plus 3 is less than or equal to -5. Well, now we need to move the 3 over to the other side so we can get x more by itself. So we're going to subtract 3 from both sides. And we get 4x is less than or equal to -8. Now the only thing we can do to get x by itself is divide both sides by 4. But because I'm dividing by just regular 4, the sign is going to stay the same. It will not switch. And so it cancels on the left, and we get that x is less than or equal to -2. So what do we know about this? Because I have the equal to bar underneath the inequality symbol, that means we're going to use a closed dot. And am I going to shade to the left or to the right? Well, because it's less than, we're going to shade to the left. Remember, the arrow points, or the inequality symbol points in the direction that you should be shading. So we're going to put a closed dot on -2. And we're going to shade to the left. And this keeps going forever and ever, so eventually we just put an arrow to indicate that. What about for example number 3? We want to solve and graph our solution for -8x minus 12 is less than -4 times x minus 4 plus 8. So let's go ahead and write that down. -8x minus 12 is less than -4 times x minus 4 plus 8. Well, the first thing that we want to do is we want to distribute this -4 to both pieces so we can get rid of the parentheses. So we've got -8 minus 12 is less than -4x plus 16 plus 8. Well, we've got some like terms I can add together on the right-hand side. So -8x minus 12 is less than -4x plus 24. And now I'm going to start moving things around so we can get x by itself and the numbers by itself. I'm going to add 4x to both sides. And so on the right-hand side, it cancels. I end up with -4x minus 12 is less than 24. We're going to want to add 12 to both sides so we can get that x by itself. And so it cancels on the left-hand side, and we get -4x is less than 36. And so let me just come up to the other side. We've got -4x is less than 36. So I need to divide both sides by -4. But I am dividing by a negative number on both sides. And so that means that I need to flip the sign when I do this. And so we end up with x is now greater than -9. And so we know that this is going to be an open circle, because we don't have the equal to bar underneath the inequality symbol. And this is a greater than, which means we are going to shade to the right. And so let's just go ahead and write down our answers a little bit. We can put whatever we want on this number line. So -11, -10, -9. Just keep going. So we've got an open circle on -9, and we are going to shade to the right. And again, this just keeps going forever and ever. And so we just put an arrow at the end. And for the last one, we're looking at 1/7 times x plus 5 is greater than 1/5 times x plus 1. And so what do we normally do if there was an equal sign here? Normally our first instinct is to get rid of those ugly fractions by multiplying by an LCD. Well, if I'm looking at 7 and 5, my LCD is 35. And so I want to multiply both sides by 35. Now, because we multiplied by a positive 35, we don't have to worry about flipping our sign. If we had multiplied by a negative 35, then we would have. And so 7 goes into 35 5 times. And 5 goes into 35 7 times. And so what we end up having left over is 5 times x plus 5 is greater than 7 times x plus 1. And so now that we've got rid of these, we can just distribute, so we can get rid of the parentheses. We've got 5x plus 25 is greater than 7x plus 7. Just going to rewrite this to the right. I am going to subtract 5x from both sides. And so it cancels on the left. And we have 25 is greater than 2x plus 7. We want to subtract 7 from both sides. It's going to cancel on the right. And we end up with 18 is greater than 2x. And the last thing we can do is divide by 2 on both sides. And so we end up with 9 is greater than x. But remember, if we want to write it the other way, if we flip the sides, we have to flip the sign. So this is going to become x is now less than 9. And so we're going to have an open circle again. And we are going to shade to the left. So let's go ahead and write our numbers down. So open circle on 9. And we're shading to the left.